Welcome. This is Design 301. It's our lecture on Tuesday, November 10th. Please remember that tomorrow is a holiday. No office hours, no open lab times. The VMware will still work, but who wants to work on a holiday? You guys hopefully will be paying honor to our veterans because it is Veterans Day. So we want to pay honor to our veterans who have served the country in our armed forces. If one of you are a veteran, thank you for your service and congratulations on being a member of a great group of people. I was never in the armed services myself. They stopped the draft about 2 weeks after my 18th birthday. And then I was in college, and so I didn't have any bone spurs, though. Anyway, so there we go. So we're going to talk about a few things. We're going to talk about attribute blocks. So I did that a little bit, and I know that Janice for sure needs to hear about these. I don't remember what Nia is working on or Oleg. Jake, you don't really need this, but you can listen in because it's good knowledge. And Brian, if Brian is still on, Brian is kicking on and off and on and off. He won't really need it, but it's kind of cool. So we'll talk about attribute blocks. If you're mechanical, it's how you do make a list of materials. And so landscape, interior design, mechanical, all need that. And then we'll talk a little bit about strength analysis. Now, this is all kind of extra stuff. It's not technically part of this class that you would have to learn how to do this. But I like in my classes to show you the types of things that AutoCAD can do so that when you get to it, you go, I remember something about that from a year ago or 6 months ago or 3 weeks ago. So you've sort of seen it. So you don't have to be good at doing this, making attribute blocks. And you don't have to be good at doing this, making list of materials. And you don't have to be good at all about strength analysis. But I think it's important that you understand how AutoCAD is used in industry so that when you do get a job, it's not like, I thought I was just going to draw. No, you're going to do all these things. And in our program, we will teach you how to do all of this stuff. Okay? So let me start, and I showed you a little bit before on attribute blocks. So I'm going to use this example here. Here we go. Oh, where's my one I saved? Now I have to go find one. There we go. So here's a little layout. This is from the college. This is a drawing that came to us from the college. Here's the tech ed area. And you can see normally we would be in this room right here, room 309. It's a lab. It's 1,200 square feet. Its use code is 210, which is lecture lab. And there's doors identified. So this is a drawing that's used for planning purposes of technical education. And we're getting a new building. And all of this stuff right there is getting torn down, as well as that stuff. That's all going to be torn down. A new building is going to be put up, and then all of this is going to be torn down. So if you've been on campus before and you recognize that as the tech ed area if you've been on campus before. And then you recognize that over here is a big parking lot, and they have what's called the computer mathematics complex, which is a bunch of portables out in the parking lot. Well, half of all this is going to go over there. Okay? It's like, yeah. Well, no. What is funeral services? What do they do in funeral services? We have the only funeral. Yeah, we teach people how to be morticians. And well, no, probably not. However, our new building will have a chapel, a mortuary. It'll be a full service funeral service facility, which is kind of cool. I'm glad you were able to see that. That's pretty cool. So, anyway, over here, what you'll see is a little bit of a layout. And this is going to be where we're going to have to put room 309. And they asked me for a plan. And so I laid in, this is the size of a workstation that we have for our computers. And I staggered them. Why did I stagger them? Because when we go back to face, it is likely we'll be in what's called hybrid operation, where some people are in the classroom, some people are remote like you are now, and we'll have to maintain a 6-foot distance between students. So that's one way that we can potentially accomplish that. Okay? So well, that's the life of remote working in the internet, isn't it? Jake, be quiet. Okay, there we go. All right. So that's what we've got. That's how it's going to work. Okay? So now, what do we do with this? We need to put this in here, and if I put Jake, I muted you on purpose. I need your microphone off. Okay. Thank you. Okay. So Jake, my microphone is working just fine. It could be that the internet is having a problem or something else, but I'm recording this so you can watch it on a recording later. Please don't interrupt now. Okay? Thank you. All right. Thanks. All right. So, if I want to be able to find out stuff about these workstations and be able to transmit this and have it come out to the list of materials for our architects, I'm going to go ahead and in this model, I'm going to put what's called an attribute. And so I'm going to make an attributed block out of this. So there's my workstation. Now I'm going to zoom in, and remember, I could define an attribute. But the first thing I'm going to do is I'm going to do my DT command. DT command, and I'll do a right justification just because, and I want to write down very small. I want really small letters that you can barely see. And I want to be able to write what this is. So it's my asset. I want to do the basic size. Okay, I want to put, so Jake, you need to stop asking questions right now. I've been over that before a couple of times, and I'm giving a lecture right now. You can ask those questions during the lab, okay? So I've asked you not to interrupt right now. Watch and learn, and you can ask questions during the lab. Okay, a spec, I probably need to know the power. Okay, and I'll put down a mark number. So now, each of those are some things I want to know about each workstation that I put in. So those become what's called an attribute. It's a piece of text that tells me about something. So my first attribute is the asset. And I just put the same thing in each one of those. And my text height is going to be small. And I can make it invisible, but I'm not going to right now. So there we go. And I know it looks funny to say asset and asset, but this one is a piece of text which will always show up. And this one is what I'm going to always change. So now I've got another one that's called size. And I've got another one called spec. And another one called power. And this is just all information that my construction management team wants to know. Okay, now, when I make a block out of these, create a block. And remember how I said that sometimes things are in there a couple of times? So I'm going to call this one workstation ATT, that it's got attributes. And I'm always going to put my workstation in on a corner. And I'm going to select my objects. And I select my text, my attribute that changes, and my other part. And I go, voila. And it says, what's my mark number? Well, number 1 is going to take probably 0.2 amp at 110 volt AC. And my spec is computer HP desktop. Oh, I'm that's terrible. Computer HP desktop high power size. How big is this thing? I think it's 48 by 30 by 30. And the asset is called workstation. Now, every time I put one of those in, that's going to show up. Or, come on, I know I can copy those in. Or, I can copy all of that. Okay, now those are all in there. The only thing is this one is mark number 2. Sort of like, which one is it? This one's mark number 3. And this is the type of work that you do when you work for an architect. You're always going in and taking care of details like this. Number 4. And some people say, wouldn't it be great if that was automatic? And I say, no, you wouldn't have a job if that was all automatic. So now when I come over to here, I've got those in there. Okay? Now, why is that important? There's a thing called extract data. Extract data. And I'll make a new data extraction. And this is something that you can save. And I'm going to select objects. Shoot, I can't select them because I need to be in my model. There we go. Let's try it again. Extract data, create a new one, go find it, where I'm going to put it. And of course, you would have this already built up and ready to go if you did this a lot. So I want to count my workstations. So I want to take those objects and I want to use my workstation. How many of those do I have? And what do I want to know out of it? Okay? So I'll take everything out of it right now. No, I don't need I'll take that information. And there's my list. That's how I make a list of materials. I've got 4 things called workstations. There's mark 1, 2, 3, and 4. I can sort different columns. I can even move them around. So now this is what's called a list of materials. So if you're doing landscape, you can see how easy it is. You just count up all your plants and export the list. And I'm going to put the data in a table. Right there. And then, of course, if I need it to be bigger, I can do that. Or I can take it from there and put it over here, someplace where I've got it. That's how you make a list of materials. It's called a data extract. Now, you don't have to learn how to make a data extract in this class. You learn how to do that in Design 310. But I want you to know why you're making these attributed blocks. So now I'm going to answer Jake's question. The attribute part is this writing right here that changes every time. That's why they call it an attribute. Okay, let's look up what attribute means. So here's what an attribute means. I'll put it over here. There we go. So this is what an attribute is. It's a quality or feature regarded as characteristic or inherent part of something. So a workstation has inherent features. There's a certain amount of power that it draws. There's a certain size that it is. There's a certain spec for it. What attributes do I put down? It depends on who I'm talking to. In this case, the people that want to know about moving our equipment want to know this stuff. So I'll make attributes for the block. Okay? And then I can just put the block in and bing, 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 away it goes. And I can actually count them up. Okay? So, and there are other ways to make these lists of materials, but that's how you do one. Isn't that cool? So that's a list of materials. Okay, at this point, now I'm open to questions. Anybody have a question on that, Jake? Did that make sense to you? So I'm not trying to teach you the content. I'm trying to teach you the idea. If you want to know, listen to me first. If you want to know about something, you have to study it in great detail. I'm not asking you to do that. And in yours, you're not asked to do that either. Okay? When you're asked to do it, it's about something you know about. Or you have to go study it. So you learn about power and things like that in Design 310, 328, 325, 330, 340, 350, and 360. So you have plenty of places to go to learn about that stuff. I'm trying to get you to think about how AutoCAD is used. Okay? And the specific attributes somebody will ask you for depends on what they want to know. You design them or know them or look them up or find them out. It's called research. Research. Design 300 will help you learn how to research. So will reading across the disciplines. RAD 315, I think. Those are two classes that help you learn how to do research. Okay? Cool. Okay. So, That's that part I wanted to make sure that I showed you. That's attributed blocks. Now in landscape, you would do the same thing, but each bush would have, or tree, or shrub, or flower would have the information that a landscaper would want. What information would a landscaper want? Well, if you're planting a tree, you might want to know how big the tree grows, how much water it takes, how long it lives, what kind of soil it needs, what kind of sunlight it needs. Those could all be attributes depending on what you need to draw. What would interior designer, so Janice, yours would be things like, once you've made your simple shapes, which I saw that you did a very nice job on your submittal on Sunday. What would you want to know about a cabinet? What kind of wood it's made out of, or melamine? So the finish would be important. For yours, it doesn't show a depth, how far in and out. So you might have that size. You might have something like the type of hardware that's on it, or the type of hinge that's on it, or how many shelves there are in it. Those would all be, or if there's lights in it. Those would all be things that you could add as attributes if you wanted to. But at the minimum, I'd put sort of like what material it is. Whether it's wood, oak, ash, I don't know what other real common, mahogany, melamine, whether it's a laminate or solid. You could put all of that information in if you wanted to put in an attribute into your blocks. Not necessary, but if you wanted to, and then of course you could really start making your list of materials. You could easily get your blocks from your drawing and quickly and easily have a list of every cabinet that's in there, or every piece of, I don't know what you call things like ovens and dishwashers and refrigerators. I call them mechanical devices. Appliances. There you go. Thank you. So you could do all sorts of cool stuff with that. If you're doing mechanical, obviously every nut, bolt, washer, O-ring, screw, bracket, everything could be included in it. Okay? So there we go. So that's a little bit about attributed blocks and making a list of material. Now I want to talk to you about strength analysis. And I've got two little videos here that you can watch on your own. Brian, I'm not sure if you had a chance to watch them yet, but it's how to make a model using Fusion and then how to analyze the strength. And it works almost exactly the same way in Inventor. Or you could import your AutoCAD and do this work. Now, you don't need to do this. This is not actually part of a mechanical submittal. It's way too much to ask for somebody in Design 301. But Brian, you're kind of ahead of the game a little bit in a couple of things. And if you feel like it, you can. But I wanted to show you why I suggested that you might, if you're 3D printing, change the design just a little bit. And so I called up Fusion. and I did this cool thing. And there we go. And so Brian designed a very nice bracket. It will work. It looks really good. It looks like this without all this stuff on the bottom. But then we said that maybe we're going to 3D print it. So I said, ooh, okay. I can see that this area in here might have some stresses on it, kind of pulling away and make some problems over here. So let me drop a piece down. And I went way overboard because I was having fun. And I made a bracket that looks like this. And you can imagine that the shelf locks into here and gets screwed in through these two screws right here. This screw and this screw. Screws into the bottom of the shelf, and this bracket screws into the wall right here. Now, I did a load case where I put a 2-pound weight right out here. And Brian, I'm not sure how much weight you are interested in having this thing. That's a fairly heavy load. But you saw that if I put a shelf hanging out there a ways, it can make a little bit of a difference. So I pretended I put a 2-pound weight right there, and I made this out of ABS plastic, and I wanted to see what would happen if I put just a screw right here. So I did something called a finite element analysis, which means that I apply a material, and in this case, I used ABS plastic. So all those materials are in there. And then you put structural constraints on, and in this case, hold on a sec. I locked a screw into this surface, and I just put one screw in here. And then I put the load on it that you see. And then I said solve. And I got these results. Now, what am I looking at? I'm looking at something that says my maximum displacement in inches is 0.0078 of an inch. Well, Brian, that's about the thickness of a hair. So you're not going to see this thing deflecting. It's plenty good. It's not going to deflect under that kind of a load. So it seems pretty safe. And my safety factor is at a minimum of 2. But look, it's that safety factor is way down here, where it's trying to push into the wall. Remember, I gave you that thing that said it might push into the wall. So but it's got plenty of safety factor. And let's look at the stresses. That's in megapascals. I don't know what a megapascal is. 1,300 pounds per square inch. That's the maximum stress. Well, that's about half, little less than half of ABS plastic, which is at about 3,000 psi. So this seems like a fully functional, good part. This is what you can do. AutoCAD doesn't do this, but the skills you learn in AutoCAD do. To do this design, it's just draw. Look, if I want to draw a line, draw a rectangle, draw a circle, draw an arc, polygon, a slot, a spline, mirror, right? Those are all things that you've already seen how to do. So then you just have to learn a little bit more about this. This is why we start with AutoCAD. The tool works all over the place. And then if you want to do what's called a simulation, you get to go look at this stuff, and these numbers are right. These are good. If I put a 2-pound load here, this will happen. Now the trick is how good you are at predicting the loads and the constraints. How good are you at figuring out how this part will be used? That's what engineers do and what designers help figure out. Okay? So that's a cool thing. But now, that's, maybe they go, that's a lot. Oh, and by the way, this can easily be made on a 3D printer in that direction. That's easily 3D printed. No problem. Super, super easy to 3D print in ABS or PLA or whatever you want. I would guess this is with the size of this is about on my printers, which are very slow and old, my printer would probably take about 6 to 8 hours to make this, and it would probably cost me $1.50 worth of material. So if you had 2 or 3 of these, you're talking less than $10 to make this thing. And I did all this stuff because I thought it looked cool. That's why I did that. I thought it looked cool. Okay, so now let's go on to the next thing, though, and hopefully this will come up. Hopefully I'll get this to work. I did it last night, and there's another cool thing called Generative Design. Okay, and in this Generative Design, what I did is I said, there's obstacles, starting design. Let's see. Which case study did I do? I think I did this one. So that's my preserve. Let's see. How do I see all that stuff? So the green stuff is what I want to keep in my design. This thing is essentially a shelf. Okay, and so I want to be able to put my shelf in there. And then this is my starting shape. So I set up my geometry. I set up how it's loaded. I picked my materials, but I also picked how I'm going to build it. So I can 3D print it or I can mill it. And I also picked a whole bunch of materials. Come on, where's my materials? I picked aluminum, steel, and a plastic. And the aluminum is a 3D printable aluminum. And then I went and looked at a whole bunch of results. Where's my results? Dang it! Where did they go? There we go. Okay. So now you can see what was an obstruction, what was an obstacle, a preserve, and a starting geometry. And where are all my results? There they are. There's my results. They're loading. And so it generated all these designs for me, depending on if I wanted to do additive manufacturing. So these are my results for additive manufacturing. Check them out. Some of them are pretty cool. If I want to 3D print this thing, I might make it look like that. And look, it's got a safety factor of 31. It's got a huge safety factor. I could 3D print this thing. That would really be cool. I could make a really wild shape like that. Of course, I wouldn't do exactly this. I'd do some sort of cool version of that. Or maybe I could do this one. Isn't that weird? But that could be 3D printed. Or I could look at, let's see, what's another cool 3D printed one? Let's try that one. What does that one look like? Think. There we go. That one's weird looking. So it makes all these weird things for me. And maybe I just want to look at just the ones that were made out of this stuff. But maybe I'd also want to do some that could be milled. But I could also 3D print this too. Give me a cool idea for... There's a cool looking one. So you can use these results of what's called generative design to give you ideas. And I could look at things by which one takes the most material, which one has the most mass, weighs the most. I could look at it by safety factor, displacement, part cost. Okay, these ones have my lowest part cost. Fully burdened part cost. So this is a generative design, and I can look at it many different ways. I can look at it this way as a table. So that I can say, okay, I really want one of these ones, or I want one of these ones. And this is the coolest thing ever. Or you could just look at it this way. A lot of people go right to here and look at factor of safety by mass or part cost. Or this is just an amazing, amazing tool. Okay, now, do you have to know how to use this? Absolutely not. It's not that hard, and we have help. It's called Fusion 360 by Autodesk. Fusion 360 by Autodesk. Now, believe it or not, Revit has this exact same feature to do the exact same stuff with architecture. But instead, you do things like room volume, windows, doors, areas, heat. It's incredible what Autodesk has in that version. So that's of interest right there. So there we go. So it's not too hard. It's just rectangles and stuff. If you want to play around with that, you can. Maybe not in this module, but in the next module. But I wanted to let you know what tools are available to you. And look, this is just the rectangle command. That's most, I use the rectangle and the line and the circle command. That's all I used in this. And then press pull. So if you've done any 3D modeling, you're able to do this. Now, thinking about preserves and obstacles and stresses and all that kind of stuff, that takes some work to start understanding. But we can get you through this. If you want in your next module to work on something like this, then you're welcome to do so. Okay, so if you're in the mechanical realm and you want to do some mechanical analysis, we can help you do that. And we have Alex Briggs Hamilton, who's able to even give you one-on-one assistance with your modeling. Okay, so there we go. That's called generative design, and I wanted to show you that. So that's where you can go with the skills that you're learning in industry choice number 2. You're learning about taking the drawings you've done and doing more complex work. Attributes, 3D modeling, blocks, things like that. You do not need to make bills of materials and DXFs and things like that. However, in industry set number 3, you might like to do that, and I can help you. But we don't need to do that right now. We'll take care of that next week as we go. Okay, let's take a look really quickly. That's what I wanted to cover for today. Let's look and see what comes up. Really, it's just question and answer next week. And we have question and answer at this one. Now, here's what I want you to do. Well, I'll talk about this in a minute. And what's due on Sunday? Okay, your optional module 2 is due on Sunday, and it should be ready for grading. So any questions that you've got, you can go ahead and ask me in the next couple of days, and we get them in. Here's where you turn it in. So on Sunday, your Industry Choice 2 portfolio submittal is due. And of course, you do your PDFs, your DWGs, and your template. I think it says to do that all right here. Yep. AutoCAD drawing files, PDFs, and your portfolio template. And I'd also like to have you tell me if you're doing a new selection from choice 1 or if you're doing round 2. Just say, I'm doing a new selection from choice 1 or I'm doing round 2. It'll help me know what to do. Okay, so now let's take a look and see what I'm going to ask you to do. For lab, here's what I want you to do is if you've got a question, go to the chat. Yeah, so Brian's saying, yep, they quoted $700 for 8 of them. Yeah, you don't need to spend that much money. Definitely not. Do you have a 3D printer, Brian? I think you were saying you do, right? Yeah. So yeah, I mean you're fine. You're fine. So now, what I'd like to do, if you have a question for lab, go to the chat. Okay. Let me see if this works. If I put this, nope. Kind of makes a mess of things. Let me stop presenting. So just go to the chat, put your name in there and type your question. I will answer your questions in the order that I see them in the chat. If I don't see any questions by 2:10, I'll just stop the lab. But so be somewhat specific. I have a question about my submittal. I have a question about what I should do. I have a question about how to. I'd like to show you my. So just put your name in the chat and I will answer your questions in the order of what I see in the chats. I'm going to take about a 5 to 10 minute break. I'll be back at 2 o'clock to start answering questions from the chat. Okay? So there we go. Good stuff. And I guess I'll stream that for right now so that you guys can all see what the instructions are. There we go. Okay, so I'll be back in just a few minutes. Okay, very cool. I see a bunch of good questions. We're going to start with Janice. Let me stop presenting. And Janice, what's your question about blocks? Okay. Okay. Why don't you go ahead and share your screen, and we'll take a look and see what that looks like. Okay. Um, okay, so Nia, how do you use press pull command on the Geneva gear and the angle on the tool brace? Okay, so that's pretty good. So first of all, if the press pull command is not working for the Geneva gear, it means you don't have a nice clean drawing. There's little overlaps or um, little crisscrosses or something like that. So I'll give you an example of that. Let me start a new drawing. And I'm not going to do exactly that because that'll take too long, but I'm going to oh, and then there's one other thing that you need to do. So let's say I've got this, and it's going to rotate about that spot. Okay, and so let me do an array about that spot. And let's say I've got 7 of those. Okay, see how those kind of crisscross over themselves, Nia? If you have anything like that when you try to do your press pull, it won't work. Okay? Oh, my screen's not on? Darn it. Sorry about that. Okay, so here I made kind of an array, and there's this little piece down here that's sort of in the way. And so if you have any overlapping like that, it won't do its thing. Okay? The other thing is you probably want to explode it. See how that's all one thing? To do the press pull, so it's going to be one of those two things. You either need to explode it, or you've got some sort of little overlap or gap where it doesn't think it's seeing all one thing. Okay? So give that a try really quick and see if exploding it works or if you can find one of the little things. And then for the angle on the tooling brace, here I'm going to do a little thing like this. Come on, press pull, work. There we go. Okay, so now you need something that goes straight up and down. And I'm going to show you 2 ways to do it, but this is the way I like the best. Except I've got something on there that I don't like. Okay, Okay, so I'm going to come over here and get out of conceptual. There we go. And I'm going to do that. Now I'm going to press pull that thing up like that. And now you can draw a triangle on it. And press pull away the part you don't want. Does that make sense, Nia? Okay, so that's how you do that. And let me know if the Geneva Gear one, if it doesn't work, then what you can do is email the file to me, and I'll probably have to check it out and get into fine details and find out what's wrong, and then tell you what to fix to make it right. Okay? So you can email it to me. Cool. So Janice, are you ready to go? I'm going to stop presenting. Okay. So I'm going to let you present. Yep, there it goes. How cool is that? Okay. So okay, so I see where you're at. So go ahead and do your dimension. There you go. So probably, so what happens sometimes, especially if you've got, do one of the other parts that's down a little bit lower, and let's make sure. Sometimes if there's something on the piece of paper, you can catch the piece of paper instead. Okay. Okay. So now, did it work on some of them and then stop working? Okay. Okay. So what happens is you have to make sure that it quote snaps to the actual object itself rather than trying to find a spot on the paper. So make sure that your object snaps are on. And the other thing is make sure that you're not actually measuring from a dimension line to a dimension line. It actually has to snap to the object itself. That looks really good though. Um, so you've got those all as blocks now. That is awesome. So once you've got it as a block, now you can see you could use those items to recreate any kitchen that uses those things that you feel like, right? Gotcha. Okay. Yeah. Yep. So and it's just helpful, it's like, oh, got it. Now you've got some things that you can commonly design with, and you can just fiddle around with them to meet the specific needs of any client, right? So, yeah. Right. Right. Yeah. Yeah, you do. You have to go back, and there's the thing is, if you what a lot of people do is, if they have something that's very similar to another block, they insert the block and then they explode it, make their changes and create a new block name from it. So like if one of these needed a handle, as an example, you would take that block, explode it, draw the handle, and say, cabinet with handle or whatever, and make a new block out of it. So, but there you go. Okay, that's good stuff. So now it works. See, that's all it had to do. Cool. Okay, cool. Okay, Jake, show me your stuff. You're up next. And did you see my comments from your submittal yet? Cool. Look at that. Cool. And you got a block for the stove. That's awesome. And then do I see a block for the sink also? Did you make a block for that? Cool. Look at that. You've got all your good layers. That's awesome. Remember to put a door into the bathroom. If I had to go to the bathroom, I'd want to make sure I had a door. Cool. You're muted, Jake. I can't hear you. There you go. Yeah. Cool. There you go. That's exactly how you do it. That's really good. So that's what we're looking for. So now you need to put all your basic wall dimensions on. You don't need to dimension the interior design stuff, but you want to put your wall dimensions on in layout. Okay? And then you're set. So that looks pretty good. Okay? Yep. Okay. Remember to have your doors. You have to draw your doors. You have to draw your windows. Okay. And you have to draw. Yeah. Okay. There you go. Cool. There you go. You got it. That's looking really good. So now make sure that you get your dimensions on it. Okay. And that you put the other features in that we're talking about because you have to have an industry standard drawing. Okay. And then there you go. That's looking pretty good. Keep up with it. Okay. You're not doing Revit on this one though. So keep focused on this. If you want to do Revit for the next one, you can do that. Well, I'm not going to tell you right now. Okay, well then don't worry about it. You keep focusing on this one. When you're ready to do a Revit project, then you can do it. But I'm not going to mix up Revit with this because that's not going to do you. It's not going to help you get this project done. Okay. Okay. Good. Okay. Oleg, what have you got on here? So Oleg, yeah. Go ahead and turn off your share. Jake, turn off your share. Cool. So Oleg, go ahead and share your screen and show me what you're having a hard time press pulling. Are you there, Oleg? Oh, there you go. Okay, good. Ah, cool. Okay. Yeah. So what you've got, you don't have a solid. You have surfaces because you were press pulling the things. So yeah, go back to that one. That's good. Nope. Go back to where you were with your other one. Okay, there you go. Now, what you're going to want to do is erase the two little lines that are coming away from the main cylinder. Erase those. Okay, now do the press pull inside of the block there. Okay, so that one did it. So go ahead and raise that up. I don't know why that other one is not press pulling right. No, you don't want to do that. Nope, 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 nope. That's not at all what you want to do. And you don't want to be catching on those ends. Um, Zoom in. I want to see what it looks like where your lines come up against the, yeah. Zoom into there. And click on the line. And now click on the line also. And I want to see the end point of that line. No, I don't want you to press pull that. That's not going to give you a solid. I'm not seeing how that, there it is. Okay. Really zoom in there. I don't think it's actually tangent. It could be. Okay. Go ahead and zoom out. Something's off there. Go ahead and zoom out. Undo that and zoom out. Okay, go fix that line back up so it's going to the right spot. You can just use Control Z, I think. There you go. Okay, here's what I want you to do. Zoom out, get rid of that solid that you made there. We don't want that. Okay, do the trim command and get rid of the big get rid of that part of the circle. You can type TR for trim. There you go. Now press pull that thing. Okay, so there's something else wrong somewhere there that it's not allowing that to press pull. Okay, hit exit or escape. Type BO for boundary. BO. And click inside that area somewhere. Where's your command line? I can't see your command line. How do you know what you're typing? So you might have to type command line if your command line is gone. There it goes. So BO boundary, BO enter. Try that again. BO enter. Enter. Okay, type boundary. It's not liking that for some reason. Enter. Huh. You're not getting the dialog box to come up. There should be a dialog box. There's something really messed up with your AutoCAD here. Boundary creation. Well, I'm trying to find. Okay, type dash BO. Dash BO. Put a dash in front of it. No, it's between the 0 and the equal sign. There you go. Dash BO. Enter. Okay. Specify internal point. So go click inside there somewhere. There, click. Okay, see where that little red thing is showing up? There's a problem there. There's something wrong with the file right there. And I don't know what it is. I don't know if you have to trim something or move those apart somehow, or if you have two lines crossing on top of each other. But that is a point that's keeping you from getting the work done. So, and there's another one. Yep. So you have to figure those out somehow to get that base part of the drawing correct. If you want to email the drawing to me, I can play with it. I'm pretty good. I've made every mistake that can be made about 100 times. And so I'm pretty good at finding out what's wrong. So if you want to email the file to me, I can find out what's wrong and then tell you how to fix it. Normally, if we were in class, I'd just walk over and fiddle around with it for a while, but I can't do that because we're remote. So just email this file to me. I'll figure it out and I'll email it back to you, and then you'll be able to proceed. But that's why it won't press pull. So there we go. Okay. Oh, that looks really nice. Look at that. That's really well done. That's exactly what we're looking for. Cool. Yep, that's exactly how we're looking for it. So that looks really good. So yeah, you can put these together into one. Seeing extra good work is always excellent, but that's exactly what we're looking for. Good. That looks awesome. Cool. All right, so go ahead and email me, and then we'll be set. Cool. That looks really good. You can stop presenting. Okay, does anybody else have questions? Okay, then I'm going to go ahead and log off. And let's see, I better save this. No, I better not save this. Cool. And I will remember tomorrow is Veterans Day, so nothing going on tomorrow, and I'll see you guys on Thursday. Cool stuff.